Thanks everyone for joining this session. As Pratik said, today we will talk about SageMaker, specifically about how SageMaker can help data scientists and also a machine learning developer. What I like to do is that probably for the next 45 minutes or so, I'll talk about some of the features that is there in SageMaker, and then probably you could have your questions in the chat, and then we can go back and I'll try to answer some of the questions that is there in the chat. Right in the last 7 or 8 minutes, I'll do that. So let me get into the session. So this is what I'm going to talk about today. Give you overview of why SageMaker, what does SageMaker brings to the table, and then we will very quickly talk about some of the no-code ML tools available. I'm not going to spend too much on time on it because I understand a lot of you are companies who are like the ML startup companies. So so I'll just quickly cover on that if at all that is required for somebody. But then we will go talk about SageMaker Studio, which is our integrated ML tool. And then we will talk about what are the capabilities SageMaker provides around your feature engineering, your training, hosting your model. And then we will cover it off with ML Ops, right? The ML Ops capability which SageMaker provides you, right? And then finally, I'll also give you some information about where you could get more information on SageMaker and different public GitHub links that we have for if you want to get started. That would be a good place to get started as well, right? So with it, let me go ahead. So SageMaker basically it's a platform by itself. So to support both business analyst, data scientist, and MLOps engineer. If you take data science as a problem, one of the use cases as a problem, right from labeling your data, building your model, training your model, deploying your model. Once you deploy the model, you might want to basically look for any feature deviation or any kind of slippage that is happening, right? SageMaker kind of provides you an end-to-end platform that can help you basically to build your business use cases, basically, right? Specifically the ML use cases, it can help you to do that actually, right? So some of the challenges typically that you see in machine learning development, not enough ML builders. So to attack that problem specifically for the business analysts to use, we provide a no-code ML tool called SageMaker Canvas, which we'll talk about it next. And then another typical challenge that we have seen is that typically labeling the data is a huge challenge, basically, right? That too, if you have either textual data or if you have a CV for a computer vision problem, image data, typically that's a big problem. Labeling the data is a problem that we have. So SageMaker provides something called a feature called ground truth, which provides an ability for you to do this entire labeling process. In that context, we also provide you a lot of automated capability to speed up your entire labeling process, right? Be it for image, video, audio, or for text. We do have some automations that can help you to fast track your entire labeling process, basically, right? Again, that's the feature that's available within SageMaker. Typically, if you see in the machine learning world currently, there are multiple tools that is being used, right? I mean, if you want to build, probably you might want to use a tool. If you want to track experiments, there are certain tools that you use. Again, for deployment, there are certain tools. Model monitoring, there are certain tools that you use, right? That is the problem, again, SageMaker try to solve. We provide one single tool, which is our SageMaker Studio, that can help you to, that covers all the aspects of it. So you don't need to really worry about using different tools for the different features that we spoke about, right? Again, on the another big challenge with a lot of our customers that we see is that how do you take the model to production? Basically, you might have done your machine learning code in a notebook environment. You really don't want to take that notebook environment to production, right? I mean, you might want to have a proper process where you know which of the model I've deployed it in the UAT environment, which of the model you have deployed into a production environment. So you wanted a very DevOps oriented way of taking the model and then deploying the model in production. That's what we call it as an ML ops, right? So again, SageMaker provides you a tools to effectively do your MLOps capability as well, right? So that's the problems that typically SageMaker is kind of trying to solve, right? So from the perspective of no-code ML tools, again, as I said, I'll quickly go through it. Typically, if you have a business analyst who wanted to use do machine learning, we provide a tool called SageMaker Canvas. It's a feature as part of SageMaker called SageMaker Canvas. All they have to do, basically underlying it uses the AutoML capability. If they have a regression problem or a classification problem, just bring in the data, which they'll tell which is the target column, and then SageMaker quickly, basically underlying it uses AutoML. It builds the model. It just not only builds the model, it can also generate the code that it is used to build the model, right? So typically the business analyst, once they are comfortable with the training and the deployment results they get, they can generate the code and they can give it to the data scientists in the team who can validate it. If they want to make any improvement or correction, it's absolutely possible to do it actually, right? And one of the things when we developed the SageMaker Canvas is that we had the whole concept of the responsible AI in the mind, right? So during the build phase, when we are building during the exploratory analysis phase, there is a bias detection that happens. So we do provide 21 different types of bias that we identify across build, train, and deploy, and we provide it to you, right? I mean, so SageMaker Canvas, when it does the build, it does the bias analysis. While doing the training, it does again the bias analysis. And then once you deploy the model, for every inference that happens, it can give you the explainability of why certain results were created, basically, right? So we have kept in mind the responsible AI principles when we developed this canvas. So just one point over there, as I said, business analysts can use it, but then once they are comfortable with the results, if they want to go ahead and generate the underlying code or feature engineering that was used, it's absolutely on a click of a button. They can generate it and then give it to the data scientists who can look into it. And if they're okay, want to do some modification, absolutely they will be able to do it and then deploy the particular model into production, right? That's a feature that SageMaker Canvas kinds of provides it to you, right? So on the single interface capability that is available, as we were talking about different disparate tools that is there, SageMaker provides you a single interface capability. That's what we called as our SageMaker Studio. So if you see in this particular slide, right from preparing the data to deploying the model, there are typically, these are all the steps that you do it in a typical machine learning use case. SageMaker Studio, and we also support R, so that's why it says R Studio as well. But if you take a SageMaker Studio, you can do all of this feature right from preparing data to deploying your model to monitoring model within the SageMaker Studio environment, right? It's an IDE, integrated development environment that we provide. With just one single IDE, you will be able to control, you will be able to do all of these features basically, right? And so Amazon SageMaker also provides a Studio notebook environment. It's a Jupyter-based notebook environment. Again, from this studio, let's say, if your data is present either in EMR, Athena, or S3, you would be able to connect from this studio environment, right? For example, I have a lot of customers who do the data pre-processing in the EMR environment that they have. Typically, if you want to work on EMR, you might want to use a EMR Studio or something like that, right? Whereas with SageMaker Studio, you will be able to control your entire EMR cluster. You will be able to get the Spark context and work on it from the SageMaker Studio that is provided provided over here, right? Again, you could use the SageMaker Studio to build, train, and deploy your model as well, right? So that's the notebook capability that is provided within the SageMaker, helps you to do it, right? Again, the notebook is based on the Jupyter environment. The Conda Jupyter environment is what it is kind of based on, actually. Right? Again, so this is just a look of how the SageMaker Studio looks like. As you could see, you could update your model, look into the different evaluation metrics. You can capture different experiments that you've done. And if you want to go back and look into your experiment, create a chart like what you see on the right-hand side, basis on, let's say, if you have changed your different hyperparameters, and for the changed hyperparameters, you want to see what is your evaluation metric. For example, loss is one of the evaluation that you're looking into it. Over a period of time, when you change the hyperparameter, how did it change? All of it, you can visually look into it. SageMaker provides a way to do that as well, right? And then purely from a notebook perspective, some of the key features that we provide is that we provide you a single sign-on capability so that your data scientist doesn't always need a IAM user role, IAM user to go in and do it, right? We can easily integrate it with whatever single sign-on that you use, so they can just use that. It's extremely secure and completely managed. The notebook instances are completely managed and very, very easy to set up. And another interesting feature with SageMaker Studio notebooks is that, let's say you are working on currently you opened up a notebook and you're working on a 2-core 4 GB machine, right? You might want to do some very data engineering intensive work only for a short period of time. You can quickly move from a 2-core 4 GB machine to a 4-core 16 GB machine, or any type of machine for that matter, even a GPU machine, with just single click of a button. You don't need to stop your instance, restart, or things like that. Just change the instance type, it comes at the background, and you can just start working on it, right? And we make it, so that's one interesting feature that we have. The next interesting feature is that we make it very, very easy for the notebooks to be shared across the data scientists. Let's say in your team, there are 2 data scientists working. I'm one of the data scientists who have, in my notebook, I've installed some system libraries. I have some outputs in my output cell. There are certain things I run. In a single click of a button, I can take this notebook, it generates a link, I can give it to the another data scientist. Once they click on the link, they get the exact same copy of the notebook that I'm using, which they can continue to start using it actually, right? So we make it very, very easy to do a collaboration and start using it, right? So that's the capability which the SageMaker notebook kind of provides it actually, right? So that's on the notebook SageMaker Studio and the notebook feature within the SageMaker that is available, right? We will talk about some of the features that is available as part of the SageMaker. I'm not going to talk about all of the features that is there. I've picked up few features that might be of an interest to this audience, and I'm just going to talk about it. From a feature engineering perspective, the first feature I want to talk about is the SageMaker processing job, right? With any machine learning training, before you do the training, you might want to process your data, basically, right? So that is where you might have done your feature engineering, and you might have created your own script to do this processing, right? Or you might, as an example, I told somebody might be using a Spark environment basically to do the feature engineering as well, right? And that is what SageMaker processing job helps you to do it. It's an API that SageMaker provides. You can tell us that what is your script that, let's say if you're using a Python script, you can tell that, hey, this is the Python script that I'm using. This is where my raw data is present. And then go and in the API, you can say that this is the machine in which I want to machine. When I say machine instance type, let's say you say that a 16 core 64 GB machine, I want to run the pre-processing and just call the API, right? SageMaker will bring up that instance. So if you look into, just give me 1 second. I'll just minimize this. Yeah, if you could look into this, right? So when I call the API, what we will do is that we will bring up the instance. Inside the instance, we copy the container. You can bring your own container, or there are some default containers that is available as part of SageMaker. Bring the container, we will copy the code. Let's say if it's a Python code, we copy the code into this processing container, copy the data from an S3, do the processing, and then we write the output back into this S3 bucket. Probably this is the training data, the pre-processed data, right? We write it back into this S3 bucket. And we also provide you a way to create clusters of it, right? I mean, you might want to distribute the data across, let's say this is a CSV file out here or a Parquet file out here, right? You might want to distribute the data across multiple different instances and then want to do the processing, right? Absolutely possible to do it, right? As an example, I just have a sample, the piece of code over here. So here, the customer wants to use, they have written the pre-processing code in a pre-processing.py. So before that, they're saying that I wanted to use one of the container. This is sklearn container, process container that we have. So this is one of the default containers that is available. But if you want to bring your own container, it's absolutely possible to do it, right? So I say that use the sklearn process container and run it in a M5 large machine, right? So this is a machine with a certain CPU and memory. In this case, I'm going to run it with only one machine, right? One instance is what I want to do a pre-processing. But let's say if I want to do a distributed processing, I can increase the instance count as well, right? For the cluster basically can work only for certain type of a data where it can be distributed like a CSV or a Parquet file that is supported for distribution. Once I define the container, all I have to do is that I'm saying that where is my code, which is the code that I want to run it on top of my data. I say that where is my input data source is there. And then I say that once the input is then, where is my output basically need to be copied into, right? I mean, basically as a train, validation, and a test data set, that's I need to be copied, right? This is all I have to say. Call this API. When I call this run API, we will bring up, SageMaker brings up this M5 large machine, will copy the data set into this machine, run the pre-processing code on top of it, and then write the output back into S3. And this M5 large machine is destroyed after this particular process is over, right? Let's say it took about 2 hours to complete the process. You are going to get charged only for these 2 hours for this M5 large machine, right? And another important thing is that we provide this as an API, right? So you can call this API sitting, I mean, from your laptop as well. Doesn't mean that you have to use the SageMaker Studio notebook environment that we provide. You can very well use this from your laptop or your Jupyter notebook or environment, or for that matter, any Python environment that you are going to use. You will be able to call the SageMaker API and offload your pre-processing into SageMaker actually, right? So that's the feature that the SageMaker processing allows you to do it. In the next feature I want to, and also if you have any questions on whatever we are talking, please put it in the comments, please put it in the chat so that we can come back and answer it as well, right? The next feature as a part of feature engineering I want to talk about is the feature store, right? So what feature store, typically a lot of our customers use it when they have multiple data science team. And so typically what happens now is that every data science teams go and create their own set of features, right? For example, let's say if there is a customer object, right? Every data science team might want to use the customer object, right? So they end up going and creating the same set of features or maybe slightly different set of features. Each team does it. So there is a lot of duplication of work that happens actually, right? So feature store as a concept is to see if there's an ability to share the features across different teams. And that is what the idea of feature store is. And SageMaker provides you the whole feature store basically, right? In feature store, there is a concept called an online and an offline feature store. So online feature store is typically used for real-time inference kind of a scenario. You use an online feature store, and offline feature store is used for your training. And if you have a batch kind of inference workload, you will be typically using an offline feature store basically, right? So the difference is that the online feature store where you need to have the response in a millisecond basically. So underlying the online feature store, currently we use DynamoDB. And for offline feature store, basically we use S3 as the offline feature store. The underlying instances, the underlying capability uses S3 basically, right? So for example, the same example I talked about the customer, let's say I as a data scientist created features for a customer. I can host the features in the feature store. Some other team can come look into it visually. They can go search for it. They can access the metadata for that particular customer feature that was written. And they can probably, there are like 100 features over there. They might, for their case, they might want to use only 50 features basically, right? They can just go query those 50 features and start using it, right? They don't need to reinvent the wheel again. So that's the capability which the SageMaker feature store kind of provides actually, right? I'm not going into a lot of detail about how do you access and things like that, because we don't have enough time. But if that is of an interest, we can go back and talk about it a lot more actually, right? But for now, I'm just giving you an idea of some of the features that is available over here, right? Let's talk about the features that the SageMaker provide around the training itself, right? What are the different features to train your model? What does it provide? So the first thing, SageMaker can help you to manage your experiments, right? So let's say as a data scientist, you might do hundreds of experiments before you select a particular model, right? You might want to capture all of those experiments. So SageMaker training provides you a way to capture these experiments. It helps you to debug your experiments, basically debug and profile your experiments. We'll talk about it a little later as we go along. We will talk about it. How do you make sure that, let's say if you're using a GPU machine or a high-end CPU machine, are you using this machine effectively in your training? You might want to do a profiling of it, right? So SageMaker can help you to do that. And also it can, we'll get into it as we go along, what the SageMaker debugger does. SageMaker supports distributed training. Apart from, let's say, if you're using a framework like a TensorFlow or a PyTorch, natively there is a distribution that is supported. But again, SageMaker, over the top of it, SageMaker provides the distribution capability, both for data distribution and model distribution. If you have a, let's say, a high transformer model where you have a large data set and you want to train it, the data distribution in SageMaker could help you. Or if your model itself is very big, it cannot fit into the memory, you might want to break the network itself into multiple machines and run it. Again, SageMaker provides a very, very easy way to do that. With very minimal change of code, you'll be able to achieve the distribution capability. Again, it provides it. We also provide something called a training compiler. So for a large deep learning model, what the training compiler does is that it can look into your graph basically and decide, and it can do a lot of optimization around it. At this point of time, we do about 11 to 12 different optimization so that your whole training can become faster. As an example, there is a case study where we talk about a transformer model, which typically one of the Hugging Face transformer model, which typically takes about 3 hours to complete. Using this training compiler, we were able to reduce it to 90 minutes basically, right? So there is a lot of hardware specific changes that needs to be done in the code. The training compiler can automatically do it. Graph optimization, it does it. So there are quite a bit of work that goes behind it to reduce the overall time of the training itself actually, right? And most importantly, SageMaker training supports spot instances. Some of you might be aware of spot instances. This is the excess capacity that is available within our data centers. So at times we can give you that excess capacity in a fraction of a cost that you would be getting it in on demand actually, right? So SageMaker training can use the spot capability so that your overall cost can go down. Again, we will talk about when can you use spot and things like that, and how spot instance can be effectively used in a minute actually, right? So purely from a training perspective, how you use it. Again, as I said, for SageMaker processing, you don't need to use the SageMaker provided notebooks to use this training or deployment capability, right? All of this we provide as a Python API. So, and also through our SDK, we provide this capability. So you could call this from your own environment. You can call the training and offload the training to SageMaker, right? That's one point I kind of wanted to make it clear. And also, all of the features that we are talking here, right? It doesn't mean that if you're using SageMaker, you have to use all the features that I'm speaking over here. A lot of my customers just use SageMaker only for training, basically, right? They might have a TensorFlow or a PyTorch model. They use the training capability of SageMaker. Once that is done, they take the model and either they deploy it in their own data center or in an edge location they wanted to deploy. It's absolutely possible to do it, right? There is no other SageMaker library or anything that is necessary. Same way, I have customers who have trained the model somewhere else, and they use SageMaker for the deployment capabilities that it provides, right? Or the model monitoring capabilities it provides. So they come and deploy that model within SageMaker, right? So you can pick and choose the components that you want to use, right? Since because we are providing the gamut of services doesn't mean that you have to use for the training, deployment, or notebook, you have to necessarily use. You can pick and choose which one you want to use and then use it as well, right? So now let's get into the training part of it, right? So let's say if you're using TensorFlow, for example, right, or PyTorch, for example, you might have your PyTorch script that is created. So that is the PyTorch script that you see on the right-hand side. And as a data scientist, now you're going to make a SageMaker API call. In the create training API is the API that you would be using. You call that API. In that API, you will say that in what type of a machine you want to run the training on, either a GPU machine or a CPU machine. And again, within that, what type of a machine, how many cores and how much memory you need. You pass in your code, your PyTorch script or a TensorFlow script. And then you say that where is your data present? And then you make a call to this API, right? So this API, what it does is that it will bring up the instance that you specified. Let's say if it's a GPU instance, it brings up the GPU instance, copy that TensorFlow, copy, if you're using PyTorch, it copies the PyTorch container, TensorFlow container, the specific version that you mentioned, it copies your script. And then your data could be either in Amazon S3, EFS, or FSX for Lustre. Let's say if your data is in one of these places, it copies the data into this training machine. For example, let's say if it's a GPU machine, it copies the data into this. And once the training starts happening, as and when the training is happening, it copies the log files into Amazon CloudWatch. So in near real time, you will be able to see the metrics that is being, or the log files that is being generated, right? Using CloudWatch, you can see it. Once the training is over, the model artifact, right? It gets copied into the S3 location that you specify in the create training API call, right? It gets copied into it. And then this training instance gets destroyed after that, right? Let's say if you're using a GPU machine and the training took about 3 hours to complete, you will be charged only for the 3 hours, and this machine will be destroyed. But before the machine was destroyed, all your model artifacts is copied into S3, and all your log files are copied into CloudWatch. So at any point of time, you can go back and look into it, right? So that's what the SageMaker training does. We make it, you can just outsource the training. We do the training for you, and then the models are available basically. Okay, so while the data preparation using cluster is the same data copied multiple times. Oh, okay. So no, in SageMaker, I think the question was related from a SageMaker processing perspective, right? So that what we do is that SageMaker as an adapter to S3. And as I said, that the distribution can happen only for certain type of a file, if it's a CSV file or a Parquet file. So SageMaker takes care of doing the distribution, right? So part of the file goes to the instance 1, the second part of the CSV file goes to the instance 2, and the third part goes to the instance 3, basically, right? So the data doesn't get, it's not duplicated. So it's a different data, so you could fast track your entire processing actually, right? So that's what happens. I hope I answered that question. Is distributed training available using Spot instance? Distributed training. Okay, currently distributed training is not available in Spot instance. There are two reasons to it, right? One, so the main reason is that what happens if we lose one of the instances, right? So again, it becomes a problem in the whole scheme of things. And again, also one of the things is that currently some of the GPU instances are not available as Spot because there's a lot of demand to it. So even if you're going to use it, you might not, even if it is available, it may not really help at this point of time. So currently for distributed training, Spot instance might not be of a great use actually. Right? Okay. I'll come back and look into the questions a little later. So this is the basically how the API call that I talked about, right? You create something called a TensorFlow estimator. If you're using TensorFlow, if you're using a PyTorch, you use something called a PyTorch estimator that you would use. And then you say that what is your entry point script, right? Where is the actual TensorFlow code, where you have defined the network, where you have defined the training, that you kind of tell it in the entry point. And then you say that in what type of an instance you want to run the training. Here they say that they want to run the training in an M5 large machine, right? But if you want to use a GPU, let's say a P2 or a P3 machine, you can specify that. And you're telling that you want to run it in one instance, basically, right? If you are doing distributed training, you can specify the number of instances over here as well, right? The instance count you can specify. You tell which version of the TensorFlow framework that you're using. You can pass in your hyperparameters that you want to use. And then which are the metrics that you are interested in, you specify that. And then you call the fit method by passing where your input data is there, basically, right? So you create an estimator in your code and then call the fit method by passing in the input data. Predominantly, that's what you do to run the entire training, actually, right? Okay, so that's on the training. I mean, I do understand there are a lot more details into it, but in this, the next 15 minutes or so, I wanted to cover as much as possible to give you an overall flavor. But as I said, if there is an interest on specific area, we can come back and talk to you in more detail as well, right? SageMaker, from a training perspective, we also support model tuning or hyperparameter optimization that we call. So typically that is one of the things as a data scientist you do, right? So SageMaker helps you to do that in an automated way and it also in a faster way, basically, right? So how do we do it? We will talk about it. So SageMaker, the default mode which uses is that we use a Bayesian optimizer. You can say that which are all the hyperparameters that you want to tune. Currently, at a time, you can have 12 different hyperparameters, combination of these 12 different hyperparameters, right? And then you tell that on what basis you want to tune, right? Or you want to reduce the loss, increase the accuracy. You just tell that and you can specify the number of training jobs to run. SageMaker will be able to run this training jobs, and give you a best possible combination of hyperparameters that either increases your accuracy or whichever evaluation metric that you specify, basically, right? And the default thing that we use is a Bayesian approach that we use. So that is what kind of SageMaker uses. So purely from your code perspective, you say which are all the hyperparameter ranges that you want to use. In this case, they have said that ETA, max depth, alpha is kind of a decision tree algorithm they are using, right? And you can specify what is the range of these particular parameters, basically, right? And then you tell us that on what metric that you want to tune your hyperparameter on. So here in this case, they want to tune the hyperparameter on AUC, basically, right? But again, you can define your custom metric as well, whichever you want, you could define it. Then you define your hyperparameter tuning jobs. You say that, hey, this is the algorithm that I want to using run, and this is the objective metric, right? I mean, the validation AUC, go run multiple different jobs for me, basically, right? So what SageMaker does, SageMaker actually supports two different formats. The default is a Bayesian search approach, and then we also have a random search. It will run those number of jobs that you specified in the hyperparameter tuning, the number of jobs that you specify, and then finally will give you a result, the best hyperparameter combination. It kinds of provides it to you, right? So that's the capability that the hyperparameter tuning job that is within SageMaker does it for you. So it's extremely helps you to completely automate and also makes it extremely fast for you to do that, actually, right? One of the interesting thing with the Bayesian approach is that unlike random or some of the other approaches, it is based on the previous input, right? So one of the things you would have seen is that at any given point of time, we say that run 3 jobs up to total of 20 jobs. So if you take a Bayesian approach, what it does is that it will take, first it will take run 3 jobs, picking up some random values from it. And then once the 3 jobs are done, the output of this 3 job, the evaluation metrics, the AUC metrics of these 3 jobs are fed into the Bayesian thing that we have, SageMaker provides. And then it figures out the next best values based on this range, and based on this output, it figures out the next value, and then the next set of 3 jobs run, right? Like that, there are up to 20 different jobs are run, and finally it will give you in this range what for ETA it might give you one value, for alpha it might give you a value, right? The best hyperparameter where it was able to achieve the best validation metric actually, right? So that's how internally the Bayesian approach works, and we have found that Bayesian seem to have worked a lot better in different use cases actually, right? Random search is random, as the name suggests. I can say that a run 20 jobs, it randomly picks up 20 values and runs it. Unlike Bayesian, where the input of previous jobs, it will try to do basically explore, exploit, and things like that, right? So it does it. Whereas random, as the name suggests, is just random, picks up random 20 values, and then gives you a output of it actually, right? Again, SageMaker model tuning can be used. I mean, within SageMaker, there's a concept of 17 built-in algorithms. You could use it for that. Or if you're bringing it in a script mode, like using, let's say if you're using TensorFlow, PyTorch, or any other scikit-learn framework, absolutely you could use there as well, right? It's possible to use it in different scenarios. Okay. Again, this is the capability I talked about on the spot training, right? So SageMaker in the training supports spot training. So one best practice is that when you are using spot, make sure that you're doing the checkpointing actually, right? So what happens is that there are scenarios where you might lose your spot instance, because whenever AWS finds that they need that instance back, they might send a signal and get the instance back within 2 minutes, basically, right? In those cases, if you're checkpointing your training regularly, when the instance gets lost and we restart the training back again, we will be able to start from the last point where we left the the checkpoint, right? From there, we will be able to start it. So please make sure that if you are using spot instance and if you're running a long-running job, you're regularly checkpointing your training, and then a spot instance can be really, really useful to you actually, right? I'll just skip this for now. I mean, one of the biggest consideration is that make sure that you're checkpointing regularly your data actually, right? Another feature within training, which I wanted to talk about, is the debugging capability. So SageMaker, what it does is that basically the SageMaker debugger during the training, you can enable the debugger. There are 2 things the debugger can do. One, it can look as and when the training is happening, you can specify certain rules. For example, one of the rules that you can specify is that to see if the weights are exploding, basically, right? There are about 15 different rules that we provide, and you can also write your own rules, right? So that is one thing. As and when it is happening, these rules, it can automatically check in your training if these rules are getting followed or if there is anything that is deviating, basically, right? That's the first thing it can do. And the second thing the debugger does is that it also profiles your underlying hardware which the training is running, right? Let's say if you're using the GPU machine, well, it can tell you that how effectively you're using the GPU machine, right? Because these are all expensive machines and you don't want to unnecessarily waste, and you might want to understand whether you're using the full capability. For example, if you're using a GPU machine with 8 GPUs inside it, right? Are you using all the 8 GPUs, right? And also you're using it to a full manner. That is what SageMaker debugger can help you to do that, right? So what SageMaker debugger, the rules I kind of told is that, right? You can set up certain rules. As and when the training is happening, it copies the tensors, basically the weights, and gets it into S3. And then top of the S3, it will run the rules. For example, as I said, it will say if the weights are exploding or weights are tending to zero, or if the losses are not decreasing after 4 epochs. You can set the rule saying that hey, keep checking if the losses are reducing after every epoch, basically, right? If that's not happening, it can actually warn you. It can send you a CloudWatch event. Based on that, you can decide whether you want to continue or not, right? So a lot of my customers have written automatic script when it encounters this condition, automatically stop the training, because no point in kind of continuing over the training, right? So those are some of the things which a SageMaker debugger can help you actually, right? I'll quickly, so basically this is the analyzing the error, this is the profiling part of it, tracking your GPU and CPU utilization and things like that, right? So you could do it over here, right? And we support this across the different frameworks, right? Be it your TensorFlow, PyTorch, or even statistical algorithms like XGBoost. We do support this debugging capability that we have actually, right? Distributed training, as I said, currently we support on top of the native distribution provided by TensorFlow or PyTorch. This is a distribution which SageMaker provides, because we identified that there are certain issues with the distribution, the capability that is provided by these frameworks, right? We try to solve those problems basically. And the point here is that with very, very small changes in your code, you will be able to achieve either the data distribution or the model distribution, basically, right? There are two types of distributions that we support. From the data distribution perspective, what we do is that we distribute the data across different nodes that you have and then run the training. So if you have a large data set, it can help you to reduce your training time itself, basically, right? So that's what the data distribution does. The data parallelism library that SageMaker provides helps you to do it. And then if you are using the large transformer models, there is always a challenge in the memory amount of GPU memory that you have, basically, right? And these days, the model sizes are so big that the models don't fit into the memory in the GPU memory. So what the model parallelism library does is that it splits the model, the network itself, into multiple different instances it can run, right? So think about it. I can distribute the model into 3 different instances. So the forward pass happens in the first instance and then goes into the next instance, and the third forward pass happens in the other instance. And the same way, the backward pass also needs to come back, right? SageMaker completely takes care of breaking the model into different instances. In what way you have to break, again, all of it is taken care by the model parallelism library that SageMaker provides, right? So that's again a capability, very easy to implement with very, very few lines changes of a code. You should be able to implement that actually, right? I'll get into the hosting part of it. We spoke about training. What are the different options that SageMaker provides in hosting? So SageMaker predominantly provides 4 different types of hosting your model, basically, right? If you take real time, if you want to have your model as a real time, we provide a real-time inference. Basically, you can say that, hey, this is where my model, this is my TensorFlow model, and this is where the model is located. And you can say that in what type of an instance that you want to run. It will deploy the model in a particular instance and then provide you an endpoint which your application can start calling, basically, right? You can do things like A/B testing over there. So things like that, and you can also do automated scaling, right? When the number of requests increase, the underlying instances can increase, basically, right? In a horizontal fashion, it can increase actually, right? So that's what the real-time inference provides. We recently came out with something called serverless inference. So it is based on the Lambda architecture that we have, right? The serverless architecture Lambda. So we can deploy the model as a Lambda. But then again, you should be aware of the typical Lambda problem, like the cold start will be applicable over here as well. And currently Lambda supports only CPU, right? So if you have a problem statement where you want to have a GPU, serverless inference cannot be used. But if you have a model where it is not, where you're okay with the cold start, serverless inference could be a good provides you a lot of benefits in terms of the ROI actually, right? So that's on the real time, right? But there are we have customers where they want to have near real time, but the payload size is extremely large, right? A lot of computer vision workloads where the payload size is extreme, it's large, and also the model takes more than 15 more than 1 minute to return the response back, basically, right? For those type of use cases, we suggest something called asynchronous inference. So where we provide you an endpoint, you can call the endpoint, we put the data, we put the request in a queue, and then we process the request and write the response back into S3 basically, right? And then you can get the response back after that. So it's an asynchronous inference that we provide. Again, that's the capability that is available. And then finally, we also provide the batch transformation where you can say that every day at a certain time, I want to run this batch inference, or you can say that based on a certain event, I wanted to call this API, right? So in those cases, you can use the batch transformation, and you will be charged only for the amount of time that the whole inference run, right, in the batch transformation, basically, right? So from a cost perspective, real-time inference runs 24/7, and you need to pay for till you bring it down. Serverless inference, you get charged only for the amount of requests it's processing, the number of requests it's processing. Same way with async inference, when there are no requests in the queue, the machine won't get charged for it. Batch transformation, again, based on an event that you're calling, and it will do the processing. Once the processing is done, your infrastructure goes down. You pay only for the amount of time you did the processing, basically, right? So that's what 4 different deployment options to use for different use cases based on your need, basically, right? So that's what the SageMaker deployment options provide. I want to quickly talk about model monitoring aspect of it. So SageMaker does 2 different types of model monitoring. One, it can help you to find the feature drift that is happening, and it also can help you with the concept drift, basically, right? So with the feature drift, what we do is that we take your training data, we run the DQ framework on top of it. I mean, you don't need to worry about what is the underlying framework. You just make a API call to create a baseline out of the training data. We run the DQ algorithm on top of it and create a baseline of your training data. And then we have this information, and then as and when the data is coming in for inference, we keep capturing the data and periodically compare your data that is coming with the training data from a statistical perspective, and at each feature level we can tell you how much drift that has happened, right? Then as a data scientist, now you can make a call whether it's a good time for you to retrain your model, right? So that's the feature drift concept that we have. Same way for the concept drift, what we do, or a model drift, what we do is that we take your existing model, run the model through a validation data, and then create a baseline of your evaluation metrics. And then as and when the model is deployed, it keeps capturing the information. We capture the information over a period of time. As an user, you can pass in the ground truth data, right? I mean, for example, let's say if it's a churn, you're doing a churn prediction, right? Currently, the model might have predicted that you're going to churn, right, or a particular customer, but after 15 days, we get to know that the customer might have churned or might not have churned, right? You pass in this ground truth data, and then we create a validation. We actually go through it, create an evaluation metrics of it, then compare it to the baseline, and then can tell you how much is the deviation that has happened. Based on that, again, you can make a call whether you want to do a retraining or not, right? So currently, it supports for both tabular data and the feature drift, the concept drift. You could also use it for some of the computer vision kind of application as well at this point of time, actually, right? We don't have anything for textual at this point of time, but you can use it for CV and tabular data currently, right? So we also provide an entire ML ops capability. We call this as, so all of us know the typical challenges in the life cycle, right? Data scientists use notebooks to do their experimentation, but then how do you take it to the deployment? That's always a big challenge, right? I mean, You need to have an ability to version your model. You need to know which version of the model is in a UAT environment, which version of the model in a production environment. Those are some of the typical challenges that ML projects have. And that is where SageMaker MLOps capability helps you to solve those problems. We have something called SageMaker pipeline, which is a DAG-based setup where you could create your entire MLOps thing, like your data pre-processing, training, hyperparameter optimization as different steps. Once you're comfortable with the model, we provide something called a model registry, where you could register your models basically, right? So model registry helps you to version your model. Think of it like a ECS, container registry, ECR basically, right? The container registry that we provide a registry for your models basically to version your models. Once, as a data scientist, this pipeline puts the model into the model registry. From there, you could use various DevOps capability to take the model and then deploy the model either into your UAT environment or to your production environment. You kind of do it over there, right? So the combination of pipelines, model registry can help you to achieve the MLOps capability that is there. This is a subject by itself. We can talk about a couple of hours on it, but I just want to give you an overall idea on how a SageMaker MLOps could help it, right? So what I wanted to leave with you is that these are all the different links that is available. But one thing that is very, very useful, I have found it useful, and a lot of our customer also found it, is that the GitHub link over here, the Amazon SageMaker, this is a public GitHub that we have. All of the features that I spoke about, there are multiple example notebooks that is available over here. You can look into the notebook with the data, it is there. You can run the notebook, get the feel of how it works. For example, you want to try out distributed training, right? You can go look into it, how distributed training can do it in PyTorch. What are all the changes that you need to do? All of it is explained and documented very well in the notebooks that is available over here. You can look into it, and this could be a great place for you to start as well, right? So what I'll do now is that we have another 4 minutes. So let me look into the chat. Okay. Okay. So how to train the model using SageMaker training job without copying the whole data on the training job instance. So if you're using S3, we need to copy the data into the training instance, right? Whereas if you're using the EFS or FSX for Luster, you will be able to kind of do it without the copying the data. We can plug into the EFX or FSX Luster, and then we will be able to use the data from there actually, right? But if it's your data is in S3, we need to copy the data to use it actually, right? The next question, can we use the provision concurrency feature of AWS Lambda with serverless inference to reduce the cold start? Yes, you can. That is an option that is available, because end of the day, all we do it is that, if you remember about few months back or a year back, Lambda started supporting containers. So that's the same capability that we use. So we should be able to provision concurrency over there as well, right? All the features that Lambda provides you, it's available. So you should be able to do that. Yeah, right. That can help. Okay, so that's all questions I have. If anybody has any, okay, what's the average time period to start a machine and start the job, right? Okay, so it takes about, if you're starting an instance fresh, it takes about 2 minutes at least. Not 2 minutes, it takes about anywhere between 60 seconds to 90 seconds to bring up the instance and then start a job. But then we also have a feature where you can keep certain instances hot. So where you could reuse the training instances, that is also possible. But if you're starting a job afresh, it takes anywhere between 60 seconds to 90 seconds to do it, right? So that is what it currently. But then again, we also have a support where you can run the job locally within your notebook as well. So instead of specifying the instance type as like ml.m5 large, you can say local. It can run within the notebook. But then again, most likely you might want to use it when you're testing it, whether to see if the training job is starting properly and things like that. Once you're comfortable with it, you might want to do it in a bigger machine, right? You might want to outsource it basically. And then thanks everyone for your time. Please reach out to us if you have any questions on any of the feature that we spoke about. We'll be happy to help you on that. Right? Thanks everyone.
Thanks.